Now let's look at an example of normal probability. So it is a construction company that builds primarily 3 and 4 unit apartment buildings. Okay. The mean time, construction time in days follows normal distribution, and we're given the mean time to construct a triplex is 100 days and the standard deviation is 20 days. So these parameters must be known. If we don't know these two values, then we cannot compute the probability. So mean is 100, standard deviation is 20. Of course, sometimes variance will be given. If variance is given, then you have to convert that variance into standard deviation by taking a square root. Okay. Recently, the president of the company signed a contract to complete a triplex in 125 days. Failure to complete the triplex in 125 days would result in severe penalty fees. Okay. Now, what is the probability that we can complete it within 125 days? Okay, so let's move on over to Excel. All right, so the random variable X is total construction time. Okay. Mean is given as 100, standard deviation is 20, right? So now we want probability within 125 days. Okay. Remember, probability of X equal to 125 will be 0. We need to have a range of values for X, and then only you will have positive probability. Okay. So what this means is the probability that we want is this. So we want mean is 100, standard deviation is 20, and we want X equal to 125. We want this area. This area is the probability that X will be less than or equal to 125. So how do we compute this probability? First, we have to convert this X into a standard normal value, Z. So Z will be X minus mu divided by the standard deviation. So that's our Z, which is 1.25. So this is converted into Z. Now we can look up from the normal table what the probability will be for 1.25. So go to normal table. Okay, the normal table is in the appendix. Okay, and also it's in the chapter. Okay. So here Z, the integer part and the first decimal place is given in the column. The second decimal place is across the row at the top. So we want 1.25, so you have to go to 1.2 and then go to this column. So you get 1.25 is this. So this is our cumulative probability starting from minus infinity all the way up to this particular Z value, 1.25. So 0.89435. Okay. So that is the probability. 89435. Let's put it there. Now the next question is, what is the probability that completing the construction within 75 days and collect bonus? So the problem states that if you can finish it, so the problem states that if the firm finishes its triplex in 75 days or less, it will be awarded a bonus of 5,000. So what is the probability that we'll be able to collect the bonus? So here again, 75 is the X that we want. Okay. Now Z is 75 minus the mean. Okay, I'm going to absolute reference that so we can copy, divided by the standard deviation. Again, let me absolute reference that. So that is our z. Okay, so now the probability that we want is okay, so this is the probability we want. So x is 75, the mean is 100. Okay, the x is now converted into a value of z, which is minus 1.25. Okay, so this is the probability we want. But if you go to the table, you see that the table lists only values of z from 0 onwards, so 50% and onwards. So how can we get the probability for a negative z? Well, here we need to use the symmetry property. So since the normal distribution is symmetric, whatever probability that you see on the left side, a corresponding area to the right side will be exactly same. So in other words, this area with z of minus 1.25 on left, okay, the mirror image of that would be z of plus 1.25 and to the right of that. Okay, so all we have to do is to drop the negative sign and go find the normal table value, okay, which we already did here, 1.25. So that is the probability. Okay, remember, but that would be the cumulative probability for 1.25. But what we want is the tail area. So this will be 1 minus that. So that would be the area here, which is the same as area here, which is what we want. So in other words, this area is the same as that area with z equal to 1.25. Now for z equal to 1.25, if you look up the normal table, this is the area you will get. This is the probability that you will get from the table. So that will be 1 minus 0.89435. So then you have the probability that you need.